Now we look at a simple corollary, simple being it doesn't require too much proof because of Theorem 3.10. So it's a corollary of 3.10. It says that if E is a compact set and F maps E into R, the real numbers, and if F is continuous, then there are two numbers in the domain E, x1 and x2, such that f of x is between f of x1 and f of x2 for all x in the set E. So another way of saying this is if E is compact and f is continuous, then f attains its maximum and minimum values. This would be a minimum value, that would be a maximum value. So this proof just takes 3 or 4 sentences. And I notice I left the Theorem 3.10 up there. And we're going to use that in the first line. By Theorem 3.10, f of E is compact. Notice the hypotheses of the premises of these theorems are identical. Set E is compact, f mapping E into R is continuous. So we know f of E is compact. Now the reason this is going to be nice, short, and sweet is because by one of your homework problems, you are going to show that every compact set attains its minimum and maximum values. So by homework number 35, f of E attains, or maybe a better word is contains, both its minimum and maximum values. Okay, so if f of E does, that means that there's an x1 and an x2. Thus, for some x1 and x2 in E, f of x1 is equal to the minimum f of E, the minimum value among all of the f of E's, and f of x2 is the max such value, the maximum over all of the f of E's. Now in general, I would say every bounded set has an infimum and a supremum, a greatest lower bound and a least upper bound. That's always true for every bounded set. But because this is compact, you're proving in number 35 for the homework that there's actually a minimum value and a maximum value. So just a quick reminder, if you take the interval from 0 to 1, that's not a compact set. It's not closed and bounded. Nor does it have a minimum and a maximum, neither one. The greatest lower bound would be 0, the least upper bound or supremum would be 1, and neither one of those is in the set. Where this has a lowest value, a minimum value which is 0, and a maximum value which is 1. So this compact set contains the min and max. This one doesn't, because it's not compact. All right, one more line and we're done. We've basically done all the hard part. Therefore, for all x in the domain, which is E, we have f of x falling in between, inclusively in between, I guess. So again, a continuous function on a compact set contains its minimum and maximum values.